Well, hi, good morning. Thank you for joining me in my shop here. It's April 30th. Hey, that's the last day of April, isn't it? Wow, tomorrow, May. Tomorrow's May. Wow. Okay, so what about this radio here? So yesterday I determined it doesn't operate, and I tested all the tubes. Aside from finding the output tube weak, everything seemed good enough to make the radio operate. Now, so what I want to do today is try to find out exactly what is wrong with this radio before I start doing stuff to it. There's absolutely no sound coming from the speaker. Like, it's totally silent. So it does have a weak output tube, but I didn't think it was weak enough to justify complete silence. No hum, no hiss, no nothing. So probably the best thing to do is to operate the radio again to start off with and confirm no sound in the speaker, and then start making some simple tests. For instance, we can inject a bit of noise into the grid of the output tube and see what comes out, and just kind of poke around a bit, because a totally dead speaker usually means a B, well, it can mean lots of things. It can mean the B plus is missing. I think I'm gonna undo this. The B plus is missing from the output tube. But I did poke around a bit. I did check for the B plus. And I think I need to repeat a lot of this stuff here. So, okay. Another thing I really should do is I should make sure I have a working antenna connected to the radio too. So I think I'm going to have to stop for a moment and make sure this is switched on. I think it is. And we'll start up the radio and just start poking. Okay, here we go. You may have noticed neither of these lights came on, but the power is going through those lights. It's just not enough power to light them up. Okay, 115 volts, even with the lights in. Do we hear anything first? Okay, I'm going to stick my ear down there. I think there's nothing there. There could be a slight hum there. Lots of things kind of humming around in my shop here. I could be mistaken. Let's check for B plus on the top of the filter capacitor. We did this last time, right here. So I'm on the 150 volt scale. That's the 50 volt scale. 30 volts. So B plus way down in this radio. Why would that be? Is there something pulling it down? So if something's pulling it down, oh, my battery's not in here. If something is pulling it down, that something is getting hot. Well, let's see if we can find it here. Okay, let's give it a look. There's something hot down here. Now I know this doesn't come across on the camera very well at all, but this is all red here. 120, 121 degrees. Right down in here. So anything else getting hot? There's something up here. No, I think that was the light bulb. There you can see my finger. So there's a resistor down here which looks like it's overheating. And there's something else under there. 130 C. I mean, this is going to start smelling very soon. What exactly is that? So I think it's this resistor here. And something that's running this way. Can't really see it. Won't be too much longer to keep this operating. There's a big high wattage resistor running right back in there, right underneath everything. So now you can see the red this time. You can see there's two objects. One is going this way, and the other's going this way. That's got to be. Well, there's a high wattage. There's two high wattage resistors in here. Let's take a look at these a little closer. But you know, they may be hot. In a normal way. Oh, that's pretty darn hot. Give me something to poke with here. So one of them is this one back here. This one right here. Well, you can see it clearly in the other one is the one that's hidden back in here. But this one looks like it's overheated. It's a little darkened right here in the middle. Now, being up against this hot one doesn't help it any. Is this really a problem? I think we need to look at those on the schematic. They should stand out. They're both high wattage and they're connected to, this is the rectifier tube. No, this is the output tube. This is the rectifier here in the back. I think. I look again. No, it's the other way around. This is the rectifier here. And this is the output tube sitting here. So you can see the one resistor is clearly connected to the, so this is probably the power supply resistor. Oh yeah, there's a field coil in this radio. Oh yes, there's a field coil. Oh no, no, not a field coil speaker again. Oh, I'm lamenting because I just did a radio a short while ago which I got caught up in field coil issues. Here we go again. Low B plus. Well, what is the B? The B plus right on the filter is low. The whole filter, both filter capacitors. Let's look again. Okay, this is the one that's 30 volts going up there. This is the other. You know, same thing basically, and then there's a third section. Oh, the third section's the winner. The third section. Well, let's see. Now that's 75 volts. Well, maybe this resistor's gone high in here, and so the voltage drop across it is higher than expected. Let's try one side here. So it's got AC on it. I think that's what that is showing. And the other side, holy smokes. AC, so the meter kind of jump up but stay around the zero. That usually means you're reading AC with the DC meter. Let's turn it off, and what we'll do is we'll check the schematic from here. I think I'm very lucky to have this. I got this off of a forum where a fellow came on and said he can't find, he looked everywhere, can't find a schematic for this radio, and then somebody gave him this, and I've got it now too. So thank you, whoever you are. Look, there's that weird plus. Okay, here's that weird spring right here. Here they're showing how it's done. One string. It looks like they did it with one string, once, twice, and then they show some kind of a clip in here. They give the start and the finish. All these instructions on it. Oh my gosh. Yikes. Okay, never mind that. What we're really interested in here is those resistors that are overheating, and they're probably going to be, whoops, in the power supply here. So here's one here, 1 watt 1000 ohm resistor. And this is right between the two positives of the filter here. This guy's probably no longer 1000, he's probably 2000 or something like that. That's my guess. And here's another resistor here. This is the one I suspected was in there because you have the string of heaters that don't add all the way up to to 115 volts. Where's the last heater? What did they do with the last heater? This is it here. Kind of hid it in there. Now there's an interesting note on the back of the radio. It says, do not operate this radio if the light is burned out. If this light is burned out. There's actually a note that says, don't operate the radio if this light is burned out. Now this is an interesting thing in that over the years I've heard lots of discussions about these lights, that they're really important to stop the inrush current. I don't think that's true. You can't operate the set without them because the heater in the rectifier tube will get, part of it will get too hot. That would be what the suggestion is with this radio. So they have the light, across the tap in the heater. They're showing the tap in the middle, but it's not in the middle. It's off to the side because there's 35 volts dropping here, and they just want to pick off 6 volts for the light. So interesting that the note on the back actually says don't operate the radio without the light. Now maybe they were just anxious to sell these lights. That's why they said that. But it wouldn't be, I don't think it'd be an instant disaster if the light burns out. The radio's not going to explode or something. So, well, this is worth taking note of. Power line ground common wiring insulated from chassis. I'll read that again. Power line ground common, power line ground common wiring insulated. Must be this. Common wiring insulated from chassis. The common being the B minus. Another way of saying B minus here. Power line ground. So here it is. Here it is. And here it is. And here it is again. And here it is everywhere. Power line ground. So this is the B minus wire that's running through the radio. Chassis ground. Okay, so I saw a resistor and I saw a capacitor that was hooked up to, oh, look at this. 1 there, 2, 3, 4. Oh, this is not quite what I thought it was. We'll take a look at that in a sec. Plus this one out here. Just going to look for that capacitor, resistor, ground connection here. This is no, here we are. Well, no, not quite. So this is the antenna circuit is actually independent from the rest of the radio. There's no real connection. Whoop. Yes, there is into here, but is this really? Yeah. Okay, never mind what I was going to say. So standing between the B minus and the chassis is this resistor, 220K, that's typical, and a 0.2 big capacitor here, which we saw on the radio. And then look at this interesting little thing here. What exactly they're showing here, I'm not sure. Could be some kind of cover over top of this coil that's tied to the chassis, like a can. I think they would draw it with dotted lines like this. And this could be some kind of gimmick. It's a sort of a capacitive connection back to the chassis. I don't know what they're doing there. So this connection is the outer shell of the tube being connected to the chassis. That means in this radio, no, I won't say that. I won't finish my statement. Shell here, and then this is a glass tube. Okay, well, there's nothing unusual here. Let's go back to looking at this situation here. So 88 ohms. If we pull this tube out, I can measure this. 88 ohms, and the other one is 1000. This is the 2 watt. This is the 1 watt. There's another 1 watt here. Hold on, there's more. We get 2 1 watt resistors. I got to find all these and test all these low value resistors here. Hey, maybe we should read these notes before I go any further. Use a dummy antenna. Perform operations in numerical order as shown. These are the numerical orders here. Where's number 1? Operations 1 and 2 and 3, 4, 5, 6, 7. It's a little early to be looking at that, but it's in front of me now, and I should really look through these notes. You want to use your scope, hook it up this way. Adjust by bending up or down wire loop around broadcast oscillating coil. Adjust by bending loop up or down. So that's these things here. Interesting. I can't say I've ever encountered that. Chances are we don't have to adjust those, but who knows? The IF is 460 in this radio. You have to tune it from the top and the bottom. I'm looking at it now. Yeah, top and the bottom. So there's a bottom plate, hopefully with some holes in it or something to get at these. Well, of course, these are in cans, so it's probably not critical that the bottom be on to do. These are in cans and they're above. They're on top of the radio. Yeah, I think there's some more notes. Keep thinking about notes here. Notes over here. Volume control full on. Antenna and ground shorted. Tuning at that 1000 ohms per volt. That's the kind of meter you're using. Voltages. Voltages are measured to chassis ground. Really, measured to the chassis. Not to the B minus. That's a little odd. I guess the idea is there's no current flowing in this resistor, so the same voltage should appear on the chassis. Voltages are subject to voltmeter loading due to high resistance circuits. So they're just warning you, if you use a lousy meter, you're going to get lower readings here. Dial scale mounted on cabinet. The lineup pointer, tuning and calibration, be collector. Oh boy, I hope I don't have to worry about any of that stuff. Drive cord and calibration. Yeah. Any more notes that I should avail myself of before it's too late? I think I got them all. So one last look at the power supply. 1, 2, 3 resistors. Find them all. They're probably all tucked right in that area. 1 watt, 1 watt, and a 2 watt. 88, 56, and 1000. Okay. I'm saying those numbers as if I'm going to remember them, but no. I don't think I will. So I think we're going to find one of these resistors to be high. Now I'm going to read it with my digital meter here. Creaky lights. Okay, so this first one down here get down on my hands and knees to get down here. Actually, just on my knees. volts, 98 ohms rather. That's with the tube in. I said something about pull the tube out. Okay, that's the rectifier tube. try it again. $90 ohms. That's one of them. Boy, I need a lot more light in here to. And the other one, I think, can't really see the reads on it. Okay, one lead goes here. The other one, I think, is right here. Next time I push the radio slides. $58 ohms. So one of them was 56. So this is probably the 58 one. This is a big. This is 1 watt. Now, there should be another 1 watt resistor in here. So one is 56 and the other one I was measuring at 90. But that doesn't add up, does it? Let's take a look at those numbers again. So I've got, let's take a look. So I've got one at 100. That's probably this one. The other one's this one. Or the one I haven't found. I haven't found this one. This is the guy who's most likely responsible for the fall of the voltage here. 1,000 1 watt. They can't hide that one. 1,000, eh? Okay, what's it connected to? It's connected basically to the tops of the. I could find it this way. Probably that's the best way, off the top here. And there's 3 sections. Okay, off the top. Between the tops of these two. So one of them is coming right from the tube. What is that? So this is a cathode? I guess it must be. I thought this was a directly heated tube. 35Z5, so cathode. Okay. Where's 1,000? 1 watt. Okay, I gotta find it. Okay, let's find the resistor. So we have the capacitor up here. Red wires going everywhere. I'm just casting my eyes looking for a large resistor tucked away somewhere. I don't see it. Is it this? Can't be that, can it? $230 ohms. But I don't know what I'm reading exactly. The resistor's in the circuit, so. Body and dot. So if I say, this is blackened, but body, I don't know. I can't. It's, is it red? Gee, I don't know. No other big resistor in sight except for this guy. Yeah. Well, let's see where it's connected. It's connected to pin number 876. It's pin 6 on the rectifier tube, and pin 8. Pin 6 to 8 on the output tube. Pin 6 to 8. Oh, they didn't put the pin numbers here. Doggone it. Well, 8 is probably a cathode. The cathode, if I've got it right, is right here. 200. That's what I read. I read 200. So I found this guy. This is a cathode resistor with a bypass capacitor. 20 microfarad. It's got to be separate. I thought it was part of this, but it's not. Often it is. A lot of radios, one of these is actually doing this job. It's a separate capacitor. It should be sitting in here. I don't see any electrolytic capacitors in there. Huh. That's a little odd. And it should be across this resistor. It should be easy to find. Okay, we'll look again, but we did not find this guy so far. Okay, this is a 1/2 watt. This has got to be double the size, a 1 watt. Okay. Let's look some more. It's just hidden from view, and I just have not spotted it yet. Or, again, we've got this one here, which seems to be a bypass. This one, and this one. And then there's one more. There should be one more in here somewhere. One more 1 watt resistor. Son of a gun. So I can trace these red wires which come off of here in hopes of finding a place where somebody stuck a 1 watt resistor, but if it was up here I'd see it right away. Can't be missing. If it's missing, that would explain that would certainly explain why the radio doesn't work. Okay. A 1 watt resistor must be right in front of my face, and I just cannot, for the life of me, spot it here. 1,000 ohms. Where are you? It's missing in action. Missing in action. Let's just take a look in here and see what we can find. I think I'm going to have to force the focus on this. Just bear with me a moment. There's a nice clear view of things. So I'm looking for a 1,000 ohm resistor in there. I don't see it. I don't see it there. So you can see the 56 one. You can see the green blue quite clearly. Oh. And this other one is supposed to be 88. It's at 100. That's the one that's dropping the excess heater voltage. This one appears to be the bypass for the output tube. Appears to not have a capacitor across it, like an electrolytic capacitor. It's got this thing. What's that? That's a 20. Oh, look at that. 20 microfarads. That 25 volts. That's. I've never seen one. This is a electrolytic parading as a regular capacitor. So there it is. Let me showing the positive end. Is that correct? But doesn't the positive end go on the tube? Is this? Yeah. Ah. Basic electronics. It's pretty clear. It says positive on the left. And I must have my head screwed on backwards about this. The more positive. Yeah, that's right. The resistor causes the cathode to ride up positive with respect to the yeah, it goes up positive. So this capacitor might be backwards. Oh my gosh, is that really true? I don't like finding things like this where, gee, I think that's wrong, but look, it's come out of a factory this way. I guess who's probably wrong? Probably me. I don't like that. Yeah, okay, I'm going to leave that for now. At least I found it. Still haven't found the big resistor. How can this be? I don't know. Coffee time. It's coffee time. Okay, made it halfway down the hall of my coffee when I realized, wait a minute, this has got a field coil in this radio. The speaker has a field coil. There shouldn't be a resistor. Let's look at the schematic again. So they aren't showing a field coil here. But there's a field coil on the speaker. Oh boy. So the field coil is taken, like this is a cheaper way to do a power supply with a resistor. A better way is to use a coil here, a choke. You can shrink these. They don't have to be this big, 50-50. But of course, choke coils cost a lot of money and take up a lot of space. So a little resistor and fat capacitors get you where you need to go. But this radio has a field coil. These capacitors probably aren't 50s. This is that tubular one. Let's take a look at that. Yeah, that's why I can't find this resistor. It doesn't exist. Field coil's probably around 1,000. It says R12. It doesn't say field coil. It doesn't show it as a coil. Oh, that's a little bit surprising here because this schematic says right on it, oh, W577A. Mine's just the 577A, no W. What's the W stand for? Westinghouse. It stands for Westinghouse. Okay, so that's got to be the case. Field coil. So I can find the wires going up to and back from the field coil and find out if it still is 1,000 ohms or, oh no, we've got a field coil failure or something of that sort. No, don't do this. Okay, yeah, I'm already twice shy of field coils. Okay, here we go. Field coil wires. So there's 4 wires heading up to the speaker here. These 2 are the heading for the output transformer. These 2 are the field coil wires. One of these 2 goes up here to the capacitor, so there we are, and comes away from the capacitor, heads to the rectifier terminal here. So there's a voltage drop across this field coil. Some amount of DC is being lost. So on one side I expect to find a fairly high voltage, on the other side somewhat lower. Let's see what we get. So we're going to turn on the radio again. Just make sure everything's okay. Yes, it is. Volume down. Yeah, last radio I was working on, I got all balled up in the field coil issues with the field coil speaker because the original speaker wasn't there, and I had a spare one, but the field coil resistance is way off, 3 times what it needed to be. And in the process of trying to accommodate that situation, did I just hear a crackle out of the speaker? Trying to accommodate that situation turned into a monster. And I set that radio aside in favor of this one, which has a field coil. So there, full volume, can't hear a thing. Okay, one side of the field coil down here. Here we go. So I'm on the 150 volt scale, so there's all of 90 volts there. You know, that's enough to run the radio. Is that the output side? And then we come over here, we test the other side, and that's all that's left. No, don't do this. This would explain the silent speaker. Does this mean the field coil is actually open circuited? Is that what this means? This voltage I'm finding on the other side is just kind of a leak back coming around the bend somehow. Open field coil speaker. Power off. We'll have to remove one of these wires, maybe this one, and test the resistance of the field coil. Can I do it with it in place? With the wire in place. I mean, it's not much to take that off. If we take it off, there's no question. Let's take it off. There'd be no question. I want no question here. I could smell something burning, but no. You know, it's just probably my synaptic links are smoking in my brain here. No, don't be a bad field coil. That's, you know, I'm sure there's probably techniques to try to deal with a dead field coil. Open circuited field coil is what I should say. Definitely one of those techniques I tried on, wasn't an open field coil, but, and it did not work out. Come on off. Hold me on there. Okay, doesn't want to come off that way. Well, I have alternatives here. Okay, need a clip lead. That's the mark where the wire came from, so keep my stupidity at bay. Okay, we got some wire bare here though. Thousand ohms according to the resistance of the resistor. Maybe this is similar. Oh, wait a minute, this isn't the right place. I want it to be on the other wire. Down here. Okay, here we go. Field coil, what do you say? Oh, 590. Well, I don't know. That's probably okay. I mean, it's conductive. You do not have an open field coil. 600 ohms sounds like a... That's exactly what my other radio was looking for. Let me take the speaker to the other radio. Yeah, the other radio was looking for a 600 ohm field coil. Here it is. But I'm afraid it's busy with this radio. Hey, what happened to my clip lead? I put it on and took it off right away, didn't I? Yeah. So I'm just going to solder this wire back on. Say, field coil, not a problem. While it's off, is there something more I can do? while it's off. This is easy to clamp around. I have a clamp-on ammeter. Do I want to start doing that kind of stuff? When I operate the radio without this connected, what am I going to find out? Open circuit voltage of the power supply. How's that going to help? I don't think it is. I'm going to solder it back here. Unfortunately, this also leaves us not knowing what's going wrong with this radio. It could be open voice coil. I should do a speaker check on this. Yeah. So even with the radio not operating and no electromagnet operating, there's probably enough magnetism left in the speaker for the speaker to make some sound and for me to know that the field coil is good. Or the voice coil is good. I think, of all the things that go wrong in radios, speaker problems have been very minimal for me. Very, very minimal, which is kind of surprising because you'd think a speaker, first of all, it's vibrating, so it hundreds of millions of times. It's got to be made of materials that can sustain that kind of thing. And you'd think, wow, just given years of humidity and degradation and stuff like that. Where's my solder? I'm looking for the solder. That the speakers would warp, and they do these things. Hey, no solder. There it is, way over here. What's it doing way over there? Who put it there? So, as I say, the number of times a speaker has become an issue, very, very limited. Seems to be 2 in a row here happening though. If you have a regular permanent magnet speaker without a field coil, then you probably, something funny about the temperature of my 365. There it goes. Just took a long time to heat this up. There we go. Okay, we're back in business there. Does the speaker work? Good question. Let's get this out of here. Get this out of here too. First of all, is there any detectable magnetism left in the speaker? Let's find out here. A little bit. Probably enough. I guess you'd say, wow, if there's enough magnetism, I'm checking the voice coil. Now, with it hooked up, the voice coil is hooked up into this transformer, so can't really know with an ohm meter. Although you could hear some clicking maybe on the speaker. Would that be the case? Would you hear clicking? If you took your ohm meter and just stuck it on there? I don't know. I guess it depends how much voltage and current your ohm meter is ready to deliver. I don't hear anything. I get a resistance over there, 0.3. That's as low as I can go on this 600 ohm scale. But there's a zero. Whoops. There's a zero there. There was a zero there. 0.3. Ooh. Yeah, this reading, I'm just reading I don't know what I'm reading. We have to apply a signal. You can apply a signal here. Some of it will go into the transformer. Some of it will go through the field coil. So we'll put in an audio signal. See what we end up with. Okay, I'll get ready for that. Okay, so all I've done is hook up leads to the voice coil, and they run up to my old unreliable audio generator. It's unreliable because sometimes this band switch doesn't make contact. So, but we'll see if we can sort through that. All I got to do is just hear a little bit coming out of the speaker, and we're good. So right now I'm on the B scale, 250. Let's go up a little higher. That's 1,000. So 1,000 hertz coming out of the speaker. Yes? I hear it. Now is that really coming out of the speaker? Can't be coming out of this, can it? No, it's coming out of the speaker. So I think this is proof of a working speaker. The very weak magnetism here is keeping the volume down. Can we boost it? Can we boost the magnetism? This is a speaker magnet here. I'm going to smash this tube. Let me just see this magnet jumping. Got quieter. Holy smokes. Oh, that's way worse. I have to leave it here now. Oh yeah, magnet. Oh, oh. That's a little stronger than I thought. Interesting that. Now, what do you put it backwards? Is there such a thing as backwards with this? You can still hear it. What if I just try to give it more magnetic field from the front? That's just the craziest things I'm doing. Where'd the sound go? What did I do? Did I demagnetize it? You know, bringing a magnet up and pulling it away is a demagnetizing technique. Still hear it, but it's very faint now. Ooh. And we turn the radio on, power this, hear a difference when this thing kicks in. Leave it like this, voice coil, no problem, because there's no sound. Yeah, let's do this. Let's see what happens. Let's do this. Put that there. I left it plugged in all this time. So the concept here is field current should increase the strength of the magnet here and make the speaker volume go way up from where it is now, because I have this cranked full. That's quite a signal. I'm going to turn it down so we're not. So remember, yeah, that's all we're getting. Barely hear it. Okay, turn this volume down, power on, volume up. I had no idea what to expect, really. Well, I think that's incontrovertible proof that field coil is energized. Current must be flowing through the field coil because the radio's operating at some degree, but there's no sound coming out of it, so it's not operating to some degree. There's definitely current going through the field coil. More all the time. Sounds like it's still getting louder. Okay, so we'll take the leads off the field coil here. Off the field coil, off the voice coil. I'm saying the wrong word, but I'm sure you're smart enough to know what I really mean. I'm counting on that. In fact, most of the time. Yes, when I say something wrong, you just convert it in your head to the correct thing and attribute it back to me. That's great. I like that. Still no sound at all from this speaker. Really? Nothing at all? Or am I just too deaf to hear it? Let's see. Volume is full. I'm going to put my ear down there again. It's just nothing at all. Radio's working. What's that down there? What am I pulling on? What the heck is that? I thought that was just a piece of paper laying there. That's a weird thing. Okay, that's okay. Spoken incorrectly. I'm gonna stop for a bit now because what to try next? So what I've got is a tube extender. So that's the output tube plugged into this tube extender, and then it's got contact terminals so we can make tests from above instead of from below. There we go. So I'll be able to read the voltage. It said read it to the chassis. Okay, because the radio is the way it is and I don't have access to the B-, we'll do what it says. We'll read these voltages to the chassis. That'd be through the 220,000 ohm resistor. Voltages. So I'm going to look for B+ on the... and I can use my other meter for this, for crying out loud. For crying out loud! I just have to connect to the chassis. Okay, I like the... for these kinds of measurements, I like the indicating meter more than a number meter or digital meter. Let's get this out of here. So I'm not so confused. Just moderately confused. That'll do. Okay, so we're going to turn the radio on. We don't need these here anymore, so I'm going to get them out of here. Try not to put my finger. How did I get this on here without putting my finger through the speaker? There we go. Careful. We are ready. Still not sure about doing this ground thing here. Okay, radio. Volume down. Whoops. Oh, I never got the, so that's a 35L6. The 35L6. Let's get out the book here so we can know where the pins are on it. 35L6. L6. There we are. Stay put. Now I got to read at least one of these numbers here. So I get started. Give me. Okay, so I did know where the flashlight was a moment ago. How come I don't now? Well, that's. I'm just going to use this. No, I'm not going to use that. I'm going to use this. Just need to read one number there. 2. 1, 2, and so forth. So here we go. we're looking for pin number 3, which is the plate. 1, 2, 3. What's the voltage, Jim? So the plate voltage is all of 50 volt scale under 20 volts. So there's no plate voltage. That's why this set is not working. Tain't no plate voltage. We got to be up 80, 90, somewhere up in that range to get the tube to work. Plus this is a somewhat weak tube, if I remember right. Maybe the combination is just deadly, and that's why we got a dead radio. So that's the question. Where'd the B plus go? Is it on the other tubes? And what was the B plus, the highest that I saw in there again? I gotta look. I gotta look. Let's take that off. I don't like taking tests to the chassis. If you want to compare with the readings they got, you have to do it the same way they did it. And even use the same quality of meter to get the exact number. And then there's a variation between radios anyway, and the condition of them. If this is being done in a shop environment, the radio is worn out to some degree. It's not coming right off the factory floor when it gets into a shop. So, what is ruining this radio? So we need to find out the highest B plus and what circuit it's on and where it's going, and start looking around there. For some reason that makes sense to me. I don't know. The highest B plus. Okay, let's go back to reading it like this. And this, and power on. Now, even though I've got the dim bulbs in, we're still operating the radio with 115 volts, so it's got its regular voltage. So now we know the capacitor down here is a 3-parter. All 3 parts are involved. I thought one of the 3 parts was a bypass capacitor. So let's watch the voltmeter. So that's on the 50 volt scale, all of 27 volts. That's a little higher at 30 volts. These should be up around 100 volts. That's where they should be. Here's the last one. Hey, it's going right over. Okay. So now we're at 70, that's 75 volts. 75 volts on this wire here up to here. 75. Then there's a wire heading up to the field coil. Ooh, what? Did I turned the radio upside down. I turned it up the other way, so I'm seeing everything upside down. Right, field coil. Field coil. Field coil. So one guy here, that's it. That's the voltage into the field coil. I'm doing the same measurement I did before, I think. That's not the field coil. Yeah, it is. It's the same as going here. It's just the other end of a wire on the capacitor here. 75. So 104 on the radio. Let's go a little higher with that. That's a little low for doing this. I'm gonna push it up. How did it get low? Took a while for the radio to really start pulling. Let's see what we got now. Okay, so now we're at 85. That's getting in the range of normal. Nothing. Get that up a little bit. Still way down there. Way down there. So we say that's going to the field coil. 85. This is coming back from the field coil. Nothing left. Field coil resistance looks pretty reasonable to me. 600 ohms. Schematic shows a 1000 ohm resistor in some other version of this radio. Why is the voltage dropping so much? Because something is drawing too much current? Some tube is drawing current, it's in cutoff, and it's just going to town. You have a hot tube then. So I found the resistors up here pretty hot. I don't know. So you start pulling out tubes, but you pull out one tube, you stop the current in all of them, the heater current on all of them. So you can't do a tube by tube thing. Some tube getting hot. I don't know how I would recognize that it's too hot unless it's something just outrageous, which I don't think is happening here. I've never really, tube getting too hot. I guess, if you really push a tube, you can really heat it up. Like the plate will get hot. So these tubes are all coming. They all look very similar. This last one won't though. So these two are extra hot. That's normal. And I really can't do this. So that didn't show anything, of course. It was kind of while I got this out, let's look underneath again. Just see if we're gonna get up. There's those resistors up there. It's really a hot spot, man. You got the two hot tubes and underneath the two hot resistors. That's a hot spot. Hundreds and 60, like that. It just wow. So what would make them too hot? Something's drawing current in the radio. It could just be a dilapidated tube, dilapidated capacitors, just causing either a bias is off on some tubes, and so they're running with heavier current, or I don't know. Probably the I don't know is the right answer. Boy, I just wish something would come out of that speaker. We got to make something come out of that speaker through the radio. So maybe if I fiddle around with the detector tube grid, I can prove to myself that there's some goodness in this radio to be expanded on. Right now, no good. Okay, I got a plan here. I'm going to inject some audio using the same audio signal generator right into the volume control, where it will find its way through the audio circuits on the radio. And if we hear it, we can rejoice. The radio's off. So I'm going to do it from the B minus here. So I have another ground on. Take that off. I don't want another ground when you're doing this, or grounds in different places. Uh-oh, that's bad news. And then the input to it is going to be here. And the volume control will work. So we'll turn the volume down. Turn this guy up just a little bit here. So there's something supposedly going. And let's switch it on now. What am I hearing there? Oh, I'm hearing this voltmeter hitting the top. Okay, 115 volts. I should be a little more careful. I think I had a much higher voltage on the radio briefly. 113, all normal. Hear a tone. That's full volume. Don't hear anything. Well, so this is kind of mimicking the output of the radio circuits, where it changes from being RF circuits to audio circuits, and the audio is going in right where I've connected these guys, and nothing coming out. Let me just make sure. Sometimes I got wonkiness here. That's full blast. There's just nothing. Nothing coming. Okay, so I want to move forward now, maybe right into the grid of the output tube would be the ideal place. Into the grid of the output tube, I should grab some kind of a pointer here. I don't have one handy. Okay, now output tube grid. Good, I still got this here. The signal grid is pin number 5. Did I pronounce that right? 5. The grid is 5. So first I'm just going to tap it with the voltmeter here. This is connected to nothing. So, but with this here, you might get quite a report out of the radio. 1, 2, 3, 4. 5 looks like that. Count them again. 1, 2, 3, 4, 5. Okay. Hang on to your hats. Nothing. Nothing at all. Let me get a little capacitor here. This will be my probe. Now, didn't I check the B plus on here and it was low, and I said this is just too low to work? Didn't I already do that? And then I decided I want to hear something come out of here. Ain't nothing. Right. Let me check the B plus again. This time I'm going to put the ground. Give me a clip. I'm going to do it to the B minus here because I already have it. Let me take this off. That's even better. Take that off. Put this here. Here. A little dangerous holding onto this clip with one hand and the other one in the other hand. But I survived. Okay, once again, looking at the voltage of the plate, which was 3, which was 1, 2, 3, plate voltage. And the plate voltage is all of 30 volts. That's probably why we're not hearing anything from there. 30 volts, and the other side of the field coil one side and the other side 30 volts. So the B plus that's available is making it to the tube. The problem is there's minimal B plus available. A partial guess is because something is pulling down the voltage because it's drawing a lot of current. Can't find anything getting hot. Maybe the field coil. Why would the field coil draw extra current? Only because something hooked up to it is causing that, I think. The coil itself, what can it do? I don't know. Are we getting warm here? Yes, this is warming up. I mean, it's not hot by any means. It's right next to this tube, but the radio's only been on for a short while, so now these things do get hot. they are dissipating power. So they do get hot, but maybe warm is a better description. Now that was just a little bit warm. So is that getting warm faster than it would normally? I can't imagine it is. All seems pretty normal. I am stuck. I don't know. I think that's it for today because groceries are beckoning. I must go to the grocery store now. So I think that's it for today. I didn't really clear up anything much today. I learned a little bit by playing around with the radio. Looking at the schematic, you tend to learn more and more about the radio. So it's not all lost. It takes time to learn the specifics of the radio you're working on. So even if I miss my goal for today, in the background I'm just getting more and more familiar with the radio. Okay, that's my cover for today. Thanks a lot for watching. And we'll carry on tomorrow and just try to find something. Somebody find something.